Hey, howdy, hey. So, sorry, I apologize for that. Anyway, literal equations. So this is something that I think is really cool. Basically, we can have equations with all variables, and we can move variables using the same rules that we use when we're solving regular equations. So the rules apply whether you have a number or a variable. The difference is that you're gonna not be able to combine like terms as often or like simplify, because you won't have as many numbers that are just constants. So enough talking. Let me solve for W. So if I was solving for W, the concept of solving for W is getting it all by itself. That's what it has to be. It has to be W equals and then the other stuff. Okay, normally that will simplify into one number, and you'll get W equals 5 or something like that. But when we are dealing with literal equations, we're just going to end up with a rearrangement of our variables, basically. But I think it's really cool. So the first thing that I'm going to want to do when I'm solving equations, I always undo the adding and subtracting first, and then I'm going to undo the multiplication, division. Sad map. All right. Oop, getting ahead of myself there. So I'm going to just subtract x from both sides. Cool, whatever. I get ZW equals y minus x. I can't simplify that, but that's what I'm going to have. Next thing I need to do is move this z, and I can do that by dividing. Cancels out. I get w equals, and I have y minus x divided by z. That is my answer. That's what solving for w would look like. Now, I did a simpler one for that time, just to warm us up here, but I want to work on this first one with you guys now. So this is kind of fun. You're solving for z, which is right here, but you actually do have some numbers in there, so it's going to be fine. It's going to be whatever. Maybe we'll have a little bit of simplifying to do. But that's all. Okay. I'm going to rewrite it because it makes me better at solving. Okay. I need to move everything to the other side except z. Whoa. But there's something that is probably causing a big roadblock for you guys, because if I move the 2xy over to this side, like, there's a little bit of a weird thing because, like, I have a y here still, and then it just, like, one of them is going to be divided by y and the other one won't be, and it's just going to be weird, and probably not the option in the maze that you need. So this is going to be using the distributive property to get us out of this. So I called this last year the reverse distributive property. Technically, it's not the reverse, it's just the same thing. It's just the regular distributive property. I like to think of it as reverse because instead of taking this y and bringing it instead of taking a y and going boop boop, I'm going to be taking the y from both of my things, and it's factoring out the y. So that would give me y times 2x minus z equals 8. Cool. So this is factoring out. All right. Now I need to solve this. This time I have to do the multiplication and division first, because you do the adding and subtracting, multiplication and division, and then if you have parentheses, you gotta unpack this one layer at a time. Cancels out. 2x minus z is now free, equals, and then this is 8 divided by y. Not the best thing, but you know, it's the way that it is. Now I'm solving for, what am I solving for? Z. Okay. I need to move this 2x, minus 2x, minus 2x, negative z equals 8 over y minus 2x. Okay, and then you might be thinking, yay, we're done, but we're not. We're not. Code red, or whatever, code green, because I used green. Divide by negative 1 on both sides. This is kind of fun, so it's going to be like that. And I get z equals, and multiplying or dividing by negative 1. The nice thing is that it's just going to be the negative, or the opposite of everything. So I really get negative 8 over y plus 2x is z. All right, I have the maze on the next page because I found it. Oh, that's dumb. Okay, so they actually chickened out and did it like this. This one would be the correct one. So let me move back and show you how that's the case. So what I did was I used the reverse distributive property, or whatever you want to call it. What they did, I'll do it in a different color, is definitely easier. They just subtracted 2xy from both sides. Then they had negative yz equals 8 minus 2xy. Then they divided by negative y, divided by negative y, and they get z equals 8 minus 2xy over negative y. The thing that they did that might complicate things for you is they just took that negative that was with the y and they said, I'm gonna just move that up to the numerator, basically. I'm gonna have that affect the numerator instead of the denominator. And so they said, basically, negative 8 plus 2xy over y. And then they switched the order of these two because they're doing all sorts of messing around. We should look at equivalent expressions when I come back. Okay, so that leads me down this road. I'm going to do a couple more, but maybe I'll do this one. This one isn't too bad because you just divide by 4 on both sides, okay? So it's pretty obvious that that's going to be your next one. Okay. Similar kind of situation here. This one, though, they actually did have to distribute out. So they took the x and distributed and had x equals negative 2 plus 3y equals 4. And the reason that they had to do it that time is because if you don't, then you will always have x's on both sides, and that's like, you can't solve for x and have the x on the other side. That's not solving. So, definitely gonna do this one. Divide by x. Oh no, why am I dividing by x? That's silly. I should just divide by the thing that I want to get rid of. So divide by -2 plus 3y. Okay, and I think I wrote over it, but -2 plus 3y. Yeah, it'd be this one, because that's what my equation looked like. Kind of weird that they have the other option, but we keep going. I could not tell you, sorry, if this is one of the pieces in the maze. You might go like from there to there or there to there. I don't know that you're going to go through this box, but I do want to do this problem. So y minus x over 4 equals x plus 5 divided by 2. And I'm solving for x. I have x in 2 different spots, so I need to work on getting it in the same location. I think this is kind of weird, because if you... Oh, I guess you could go backwards. Okay. I think the first thing I'm going to do is add x over 4 to this, both sides. Get y equals x plus 5 over 2 plus x over 4. I need way more space. Okay. You guys will probably hate me, but I'm going to like do some fraction stuff here next. I have not common denominators, but I have very easy to make common denominators. So I'm going to say, well, this is the same thing as y equals 2 times x plus 5 over 4. So what I did, little side thing, is I just multiplied like by 2 over 2, because that's 2 over 2 is 1. So it's equivalent. We really need to do equivalent stuff. All right. That's our next step there. Y equals, okay, 2 times x plus 5 plus x over our common denominator of 4, which we are going to happily multiply on both sides and get 4y equals 2 times x plus 5 plus x. Okay, cool. Now I need to distribute so that I can combine like terms. So 2x, so 2 times x, got to rewrite the original. 4y equals 2x, and then the next loop is plus 10 plus x. Now I need to combine like terms. 4y equals 3x plus 10. Subtract 10 from both sides. I get 4y minus 10 equals 3x. And then you know what you got to do next. Got to divide by 3. Didn't mean to rhyme there. I get 4y minus 10 over 3 equals x. Let's see if that's actually what the answer is. 4y minus 10. So that's fun. That's very fun. 4y minus 10 over 3. That's actually this one, so it goes in that direction. So you must be coming through one of these, just so you know. All right, that is more than enough explanation. If you have more questions, I'd be happy to help you. I'll see you soon.